Okay, yeah, 35. It says we're supposed to use the x and y-intercepts to graph the linear equation. Okay, 35 was written in slope-intercept. Shh, quiet. 35 was written in slope-intercept form, so it would be easy just to use the y-intercept and the slope, but we need to practice doing what they say. So, you guys remember how we found the x-intercept or the y-intercept?
Subtract.
No.
Add.
No.
Multiply.
You cover up
Okay.
one of the others and then you...
The y-intercept happens when x is 0. So if I put in 0 for x, that would go away. What would y equal?
1.
1.
So I was right.
Which also, notice, in slope-intercept form, what's the intercept? 1. That's where it hits the y-axis at. Okay, how do I find the x-intercept? Make the y 0. If I put in 0 for the y value, I get 0 equals negative 1/2 x plus 1. How do I solve this for x?
Move the negative 1/2 x.
Subtract the 1.
Yeah.
Now we subtract the 1.
You did divide.
Divide by negative 1/2. Negative 1 divided by negative 1/2. I don't know if you guys remember middle school. When you divide by negative 1/2, you're really multiplying by negative 2. Right? So it's really kind of like negative 1. You can just plug in your calculator, negative 1 divided by negative 1/2. But really it's negative 1 times negative 2, which makes x equal to 2. We are, but we're saying that for
Is that it?
So when we graph it, basically it goes up 1 over 2.
Right. No, these are two separate dots. Go up 1 and put a dot. And you go right 2 and put a dot. And then just draw the line between them. You should be doing that now on that little sheet of paper.
Oh.
Wait, so we're doing 2 and 1.
Go
0.
up 1 over 2. Rise over run.
No, that's slope. That's not this. This means right 0, up 1. So you put a dot up 1. This means right 2, up 0. So you put a dot at right 2.
So that's why we...
And then draw a line through.
Draw a line. You get it, Devin? Wake up. Remember you just did this yesterday. Just put those dots and then graph it.
So it's over or up 0 over 1 and then up 0 over 0.
Right 0,
Okay.
up 1.
Alright.
So it's up 1. Right 2, up 0.
Then why is it called rise over run? Shouldn't it be run?
That's slope.
Yeah,
That's something
slope.
else.
This is...
Slope is something else.
slow.
I divided by a negative 1/2.
9.
Oh, wait, this do I see the numbers because like one of these like lines. Oh, line, that's a number. Should I split it? So, like 1, 2, 3.
Huh?
How'd you go now?
Okay, what? Yeah. Alright, number 37. Use the y-intercept and slope to graph each equation. So, on 37, is that line written in slope-intercept form or is it written in standard form? Standard. So we need to change it to slope-intercept. Write it backwards. We need to change it in the slope-intercept form so we can use the slope and the y-intercept. How do I change it to slope-intercept form? Right, I'm trying to get y by itself. I'm going to subtract the 2x over.
That was a good one. She said,
Why?
Stop.
You know what's bad if the teachers are telling me to stop daily?
Okay, divide by 3. We've done it so many times, I think we should. Mostly it was last year, but this year we've only done it a few times, but last year we did a lot.
Last year was confusing. I changed. No, dude, I loved it. I want to go.
Last year was
Yeah.
You weren't here last year.
The math we had.
Algebra can be challenging, that's
Hey,
for sure.
It's complicated.
Okay. Now, do you guys remember how this is not the answer. This is what we're ready to graph. How do we graph this?
You start out going up 3.
Go up 3. So on your graph, if you make your cross, go up 3 and put a dot. Plus 3 is the y-intercept. Now, Dylan, this is a slope. Right
Ah, so now I write.
Okay.
So we can go
Dylan, you see the difference between
Yes.
that and that?
Yes.
Okay. The 2, 3 thing, when it's in parentheses and there's like a comma, that's just an x and a y coordinate. Anyways, how do we use the negative slope? We're gonna go, where are we gonna go?
You go down 2.
Down 2,
3 to the left, right.
3 to the right. Down 2, right 3.
That's where you're going to.
Make a couple dots. So starting at this point, up 3, you go down 2 and right 3, put a dot. Go down 2, right 3, put a dot.
Wait, go down 2, right 3, and put it on.
Wait, this is your.
Just make 3 dots and then draw a line.
Okay, wait, and then I go
No.
up 3 to the left.
Start from here.
Four now.
Oh, I have to start at 3.
You gotta start at 3. You should start up here and go down to right 3, so it should look about like that.
I'll only do 2 dots. I'll
Do-
only do 2 dots, right?
Do another one, down to right 3.
Okay.
No, it's not.
Should look something like that.
That's David's.
My rough sketch.
Wait, what about David's girlfriend?
Okay, on 39, it says, write the equation of the line through 2, 3, parallel to. So if we're writing an equation of a line, what is our answer going to look like? If we're writing, number 39 says, write the equation of the line through. If we are writing an equation of a line, what should our answer look like?
Oh.
How did we do this? Should look like this, y equals mx plus b.
Oh,
That's the equation of a line, just like numbers 34, 36, 35. Well, 35 and 36 are in the slope-intercept form. So we need a slope to put in for m. We need a y-intercept to put in, a number to put in for b. On 39, it says the line that we're writing the equation for should go through 2, 3, and it should be parallel to y equals 3x plus 7. What do we know about parallel lines?
The slope is the same.
The slope is the same. What is the slope of the line that they gave us? 3. So what's the slope we're going to use? 3. Okay.
Here must be here.
On the next problem, you might make a note for this. They say perpendicular line. If this slope is 3, what would a perpendicular line slope be?
1 over 3.
Negative 1 over 3.
Yeah.
Okay, so this is the slope you're going to have to use on 40. Not this, not 39. That's 40 slope. Okay, anyways,
Subtract 7.
negative 1 over 3, slope is 40. Okay, so when I go to write my equation, I'm going to use the same slope.
Wait, do we have to graph these two?
No, writing equations.
Wait, did you say something about 40?
Yes,
What did you say?
slope is negative 1/3. Okay, on this one, I still need to find my B value. You guys remember how we did this the other day, 2 days ago? They told us that 2, 3 has to be on the line, which means it's supposed to be a solution for this equation. So I can plug in 2 for x and 3 for y, and that's enough information to help me find b. I'm guessing a lot of people are going to forget this
I wrote it
on
down.
Friday.
I already got it.
Okay,
What are we talking about?
I already forgot it, yeah. I plugged in the slope, I'm plugging in the x and the y value.
Yeah, I already got it.
Yep.
When's the test?
Friday.
Well, I didn't know that. Don't we have a science test from?
No.
No.
Science test sacrifice.
Oh, sorry.
Okay, shh. So how do I use this to solve for b? What do I do now?
You. make
3
it-
times 2 is 6. Now how do I solve that for b?
6 plus b equals 3, so.
You move the six over to the.
Since 6 is added, I'm going to subtract 6.
That's number.
And it's
b is -3. That's not the answer, that's just part of the answer. The answer is we're at the equation of the line. Y equals 3x, but instead of putting plus b, I'm going to put -3 in there.
Wait, I have a question. Can you like scroll up just for like a split second? See what-
That's longer than a split second.
How'd you get 2 and 3?
It said the line has to go through the point 2, 3, which means 2, 3 is a solution for the equation. It's not even plugging in.
I've been trying to since 6th grade.
Okay, Dylan, what I said about number 40 was you're supposed to have a perpendicular slope. If this slope is 3, or 3 over 1, then what's a perpendicular slope?
1/3.
-1 over 3.
Oh, I was.
So that's the slope you have to use on 40.
Okay.
Okay, now we're jumping to 15.
Wait, you're supposed to graph it.
No, it's not a graphing problem.
Is it to graph it?
They meant, that's for 36 and
Oh, we're only
37.
going 40. Oh, I.
That's confusing. Okay, 15. Guess how I'm going to start 15? It's a proof, so
It's given.
statements,
Do you write 15 on paper?
reason. Yes, write this down. This is worth points.
This is number what?
15.
Can you give us 16 too?
No, I'm not going to give you all
Can
16.
you tell us how many steps there are?
4 on both of these. Okay. Guess what my first statement or on 15 is? The well, what is the given though?
N is parallel to N and P is parallel to Q.
Yeah, you guys see where it says given on the problem? P is parallel to Q because it's given to us. So before I even, I'll pause for a second while you guys are ready.
Right choice.
Will. It's too
Funny.
Okay.
We should have a little bit.
Yeah, we should have like you can do 2 a day. Will.
You can be a special
No,
guest
he's
on the Maury
already, he's
show.
already got a limit.
No,
It's science, yeah, it's 3.
No.
It's
Well, I mean like 2 per class. 2 per class.
Yeah,
No,
okay.
just.
Never.
I can't keep track of his other classes.
It's 1 a day.
Yeah,
None
please.
of it.
It's good.
Hear me out, Will.
I said put that away, Carson.
Just don't.
All right, number 2. Actually, before we do number 2, so on the given, we know the lines are parallel. So before I even try to figure out where I'm trying to go, what do I know if the lines are parallel?
They're the same.
What's the same?
No.
Which angles?
1 and
Okay, corresponding angles have to be the same.
alternate.
Alternate interior angles have to be the same. Alternate exterior angles have to be the same. Or consecutive interior have to be supplementary. They have to add up 20. Those are the 4 things I know. So I'm going to use those 4 things. Listen, this is why you don't know what's going on. You guys don't listen.
I listen very intently.
Okay, you weren't right there, because you just talked when I was talking. We gotta use those 4 facts to prove what we're trying to prove. What are we trying to prove?
Angle 8 is, I forgot.
Angle 8 is congruent to angle 9. Do you guys see 8 and 9 in the picture?
Yep.
Alright, so we gotta show somehow that 8 and 9 are the same thing. Okay, right now, what do I know 8 is the same thing as? Angle 8 has,
9.
angle 8 has to be the same as angle what? 16. I don't know that it's the same as 9, that's what I'm trying to prove.
Well, you
Okay. How did she know 8 and 16 were the same? Right. Because corresponding
And
angles,
also M and N are parallel.
right, because if the lines are parallel, corresponding angles are congruent. Okay, you could write that out, like the sentence that I just said, when lines are parallel, corresponding angles are congruent. Or you can, it's called the corresponding angle postulate. I'm gonna use a little bit of shorthand here.
Would that also mean that 9 and 13 are congruent? Because that would mean that P and Q are parallel.
What is it?
Corresponding.
Oh. So we just said that 8 is the same as 16.
9 and 16 are outer, or exterior.
Yeah, are 9 and 16 the same?
Yeah, they're exterior. And exterior ones are congruent.
Yeah. I also know 16 is the same as 9 because exterior angle. Alternate exterior angles are congruent. Guess what that's called?
Alternate angle.
It's actually a theorem, yeah. The only postulate is the corresponding angle ones, all the rest of them are theorems. So, it's called the alternate.
I should remind you that one, okay?
Yes, you did very good. Exterior angle theorem.
What exactly is the difference between theorems and postulates?
Postulates are things you assume to be true because it's obvious, and theorems are things you can prove to be true.
Okay.
Like, we can't really, we're saying this is such a basic concept, there's nothing we can say to prove it's true, we're just starting by assuming it's true. Like, that corresponding angles are congruent if the lines are parallel. Because if the lines are hitting another line at the same angle, they're going to create the same angles, right? That's basically what it is. Anyways,
So then
alternate exterior angles are congruent. We can prove that using this postulate and using vertical angles and using linear pairs, stuff that we already know. We can prove this theorem. Anyways, got off track there. So, what were we trying to say? That 8 and 9 were the same. So far we've said 8 is the same as 16, and we said 16 is the same as 9. Is that enough information?
Yeah.
Yes. Substitution.
Because then.
Okay, I would accept substitution or transitive. 8 is the same as 16, 16 is the same as 9, therefore 8 is the same as 9. 8 is congruent to 9. The book probably put transitive.
You should put one like that. Not the exact.
There's on the test, there's a fill in the blank proof that's related to these two problems. It's not a blank proof though. Should I do that for a bonus maybe?
Yeah, you should have for bonus.
Why are you protesting bonus?
Only 2 people want this.
So,
It's bonus.
You can
Why
literally
would you
just
care?
guess on it.
if we did a bonus, I wouldn't give you credit for like the given line and stuff though. Anyway, how did we know that? What did you guys say? Transitive is probably what the book put. If you put substitution, those are basically the same thing, so I wouldn't care. It's a property or substitution. You haven't even looked at it.
Yes, it is. And it's parallel.
Okay, 16 also is gonna have 4 lines, just like this one. How do I know that I'm done on this one?
Because it,
Because I just said what I was trying to prove.
yeah.
Okay, that's when you're done. 16 is similar to 15. I will help you start, but I'm not going to finish it. So maybe I'll do the lines 1 and 2. We'll say that. If you can't figure it out, then you'll just miss a couple. This is gonna happen. Sorry. 16. There is a pretty close relationship with number 15. It's not the same, definitely different. Actually, me helping you with line 1 is probably not that much help, because guess what line 1's gonna be? P is parallel to Q. And angle 2 is congruent to angle 14. Okay. Maybe, okay, since I don't need all this room, I can use it to talk about the problem. One, two, three, 4, 5, 6. Nope. 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what do we know right now? That P and Q are parallel. Which ones are P and Q?
The 2 lines up
The
top.
top 2.
These two. Do I know that M and N are parallel? No. That's what I'm trying to prove. I'm trying to prove that these 2 lines are going to be parallel. What is some ways that we can prove 2 lines are parallel? This is probably about like last Thursday's assignment or something like that.
Oh, I remember.
We did an assignment on it.
Yeah, I remember. I just.
Anybody remember, Archer?
The lines are
Congruent means the same.
of course.
If corresponding angles are congruent, the lines have to be parallel. It's kind of like what we said on the last problem, but backwards. Last problem we said if lines are parallel, corresponding angles are congruent. On this problem, we're going to say something like, if corresponding angles are congruent, then the lines are parallel. Or if alternate interior angles are congruent, then the lines are parallel. Or if alternate exterior angles are congruent, lines are parallel. We're going to have to use that at some point to prove that these 2 lines are parallel. We don't know that right now, so we can't say. So if I don't know these are parallel, I can't say 2 and 10 are congruent, for example. Because I don't know if these are parallel
Could
yet.
you say 10 and 14 are?
Okay, so right now what I do know is 2 and 14 are, because that was given. And I also know that these 2 lines are parallel. So that means I can jump from here to here, but I can't jump from here to here with the parallel lines. Okay, well,
So since we know that P and Q are parallel, that means that 2 and 6 are congruent.
okay, yeah. So Canyon, what you said would work also. You could say 14 and 10 are the same, or we can say 2 and 6 are the same. But I can't go from here to here though.
But if we know that 2 and 6 are the same, then that would mean that 6 and 4 are the same,
Right.
since 2 and
That would be
14
line, yeah, you're getting into line 3. So I'm going to say 2 and 6 are the same. I'm going to jump this way first. 2 and 6 are the same. Why do we know those are the same? Because they're corresponding angles of parallel lines, or corresponding angle postulate.
And then number 3 is angle 6 is congruent with angle 4.
14.
That's what I meant, Will.
Okay,
Yeah.
yes, that's true, but it's not corresponding angle postulate for that one.
Oh, alternate true?
No. No. Okay, this is where I'm going to lead you. But I'll give you one more hint for line 3. There's only 2 lines left. I already said that. For line 3, you got to use a trick that we used for line 2. Or sorry, for line 3, you got to use a trick we used on problem 15. Okay. I'm not gonna give the answer. Okay.
Division.
We didn't use that on line 15.
Oh, I don't know.
Okay. The next trick is the same trick we used on number 15. They're not identical proofs, but they are similar.